Well, hello all. This is Corey Lambertson with Whitmix Corporation, and we are on our fourth session, right, Matt? Is it the fourth one now?
Yep, I think so.
He's very confident this morning, as we can all see. Um, we are on our fourth session of Ortho System Training. Once again, my name is Corey Lambertson. I'm actually the manager over the Tech Support and Training Division here at Whitmix. And we have Matthew Davis with us, who is a trainer and support technician and ortho guru, as I like to say. Actually, depends what we're talking about. He's a guru of many things. Matt, go ahead and introduce yourself.
My name is Matt. I worked in an ortho lab in Oregon for 4 years. I started working with Whitmix about 4 months ago, 5 months ago, somewhere in there.
Yep.
It's been great. It's been flying by.
It has literally been cruising by, actually.
Yeah.
This year, I don't know about all of the attendees that are watching today, but this year, I didn't realize it's February already. I mean, I don't know where January went, but I guess it happened. Um, yeah, it's just been a busy year so far. So, uh, just to cover what we're going to be talking, Matt is going to be designing a splint in 3Shape, the Appliance Designer software. And so I know a lot of users probably see the Splint Studio software, which is beautiful software compared to what we're going to see today. However, what if we wanted to design some indications where we have an upper and lower splint at the same time, or upper and lower appliance at the same time? This is the software and workflows that we would see on the ortho side if you wanted to achieve that. So just to cover exactly what this is, this webinar, we're going to demonstrate how to design a splint in a 3Shape Appliance Designer. Once the previous preparations have been completed in either Appliance Designer or Ortho Analyzer, we'll show how to make a new appliance and then cover the workflow for articulating the arch, designing the shell, applying the bar, and exporting the final STL for printing. We're also going to cover pitfalls and struggles that newcomers often experience. We'll discuss those, and then Matt's also going to give us some design tips. Also, for everybody that's watching, keep in mind that this is being recorded. If you want to watch this later, actually, I just see a question came through. Is this going to be recorded? You bet it is going to be recorded. And if you want to watch this later, you can. You can share it with all of your dental buddies. And this does qualify for CE credits. So if you need those credits, you will receive a questionnaire in about 2 to 3 days. So you can fill it out so you can apply for your credits. Matt Davis does put the questions together. And so if you pay attention closely, you should be able to pass. He's pretty strict with his questions. All right, Matt, it is all yours. Take it away.
Cool. Let's get this going, I guess. Let me pull us up here. So, minimize that. This is what you're going to see when you open up our Appliance Designer. It's the same, very much similar to Ortho Analyzer's interface. For this case specifically, you're going to need to be at least have gone through the first webinar where we talk about prepping a model. And as you can see in this bottom section here, that I've already prepped this model. So I'm going to go ahead and use this model. So if you don't know how to do that, please see our previous video that showcases how to do that and walks you through how to do that in Ortho Analyzer. But we're going to just skip that to save us some time because this splint design can take a little while. So we're going to, I guess I should probably kind of talk my way through what I'm doing here.
Yeah.
Got into autopilot mode. So we're going to make sure that we have our model set selected that we wish to make an appliance for. And there's two ways they do this, very similar to Ortho Analyzer again. You can right click and click new appliance, or while it's highlighted, you can come up here and click the new appliance button. From here, you can name it whatever you want, give it an ID if you'd like. None of that's really necessary except for just your own record keeping. But it is there for you. And as you can see, there's a bunch of different options that you can download. These are all ones that I've downloaded from 3Shape through the Ortho control panel. The directly printed transfer tray, that would be if you were doing those indirect bondings like we were talking about in our last webinar. And this one, we're going to be designing a splint.
So quick question while we're on this page, if we want to do an upper and lower splint.
This will do upper and lower.
Okay, so I don't need to change the appliance type to anything specific for that?
No. You
Cool.
can, if you wish to do something different, there are custom metal bands, but for the most part, if you're designing splints, I would just stick with the splint workflow because it's already set up and ready to go.
Cool.
A lot less customization required. The other thing to mention, at least, and I think we talked about this in our last video at least a little bit, is these production equipment and materials. They are not required in order to design your splints. I designed splints using just these default settings a ton of times and was able to export my STL file and print, and it printed correctly and accurately and no problems. The reason these are in here is they will actually have limitations set in place so that if you are using that equipment and designing your splint, it will give you warnings when you are exceeding the parameters that that printer or that material cannot print. Yep. So there's minimum thicknesses and things like that for your splints that it will give you warnings, and some of them will even restrict you from being able to design anything that is not compatible with your production equipment. For this purpose, my recommendation is anytime you're designing a splint or printing anything is to consult your technical manual from your manufacturer. So if you're using Whitmix, we have all of our technical manuals on our website with our resins. So I would consult those. They all have recommended thicknesses and printing angles and all sorts of other parameters that you should abide by. I would make sure that you're consulting that if you are, whatever your resin you're printing with, consult those technical manuals.
Now, I do have to put you on the spot, Matt. It's my job to do this. All right.
Yep.
So if you were printing with our VeriSplint resin, do you know off the top of your head what our minimum thickness is and what offset we should be going? It's okay if you don't. This is
offset I'm not sure of. I want to say the minimum thickness though is recommended at 3 millimeters.
Swing and a miss. All right,
dang
strike
it.
One. Everybody mark that. So
man.
It's actually going to be the minimum thickness we want to go with our VeriSplint. Actually, we can go down to 2.2 millimeters, so way better than 3. And then actually 0.8 millimeters better. And then our internal offset, we want to start with a 100 micron spacing, and Matt's going to explain that when we get to that point of the software. But if you're designing splints, there's actually 3 things that you need to go off of: the minimum thickness, the offset to the actual cast that we're designing on, and then there's some retention values as well that you may want to adjust to. For our VeriSplint, which is a hard splint material for 3D printing, we're not going to adjust the retention. We're going to keep that at 0. Want to start with that offset at 100 microns, so 0.1 millimeters, and remember minimum thickness 2.2. All right, Matt, take it away.
Yes, thank you. Yes, I like I said, I haven't actually printed with our too much yet, so I don't have a whole lot of experience with that. But like I said, you just definitely want to consult your resin, whatever you're printing with, and make sure that your parameters meet those requirements in your design steps. So we're going to just click next through all of these because we've already done our setup before. We're going to just right here, it's auto placement options pop up. We're just going to use what we set up for in Ortho Analyzer. So we're just going to hit perform placement, and it's going to automatically adjust everything based on our setup that we did in Ortho Analyzer. So as long as you did all those steps correctly, they will transfer over to here.
Now, if you didn't set this up in, let's say, Ortho Analyzer, or if you didn't actually create your, let's say the modeling of it, would it allow you to bring in just a simple shell and design off of it, or would it kind of freak out?
It kind of freaks out. Yeah. That's one of the downsides of Appliance Designer, and one of the upsides actually of Splint Design Studio or Splint Studio is you can use just shells in Splint Studio, and it will design most of the time just fine. I haven't run into too many errors with it with shells, but I also wasn't designing splints all day every day. So
yeah.
You can see it does transfer in the brackets. We're going to find out together if that actually will affect our design for the splint. If not, don't worry. As long as you don't go through the bracket placement in the previous steps, then they won't show up here. So no need to worry about that. For this step, we're going to be talking about removing the undercuts. Now, this is asking, it has an insertion direction set, which is perpendicular to our occlusal plane. And if we had, in this case, we do have a slightly flared central. And so what we probably would want to do is change our insertion direction. And that is actually based off of our camera's perspective. So what I'm going to do is rotate this so that I'm looking down the occlusal area of the centrals to try to get a little bit better retention there. And then I'm going to click this and set insertion direction. And you can see that changed the arrow pretty substantially. So we're going to keep that as close to the same as possible and hit next.
And so we can see real quick, now is that retention amount there, is that where we could potentially alter the retention value, or is there another area too?
So that retention amount that was set there is all having to do with your wax that we're creating here for this model to create blockouts. So you can affect your retention here. However, that's not going to be altering the splint itself. This is just creating blockouts.
Okay.
So in my personal experience, most of the doctors that I worked with when designing splints, they liked very high retention amounts, which meant very little blockouts. And some of the doctors we talked to asked us to have no blockouts at all, that they preferred to do that, by hand in the chair to make sure that the fit is as snug as possible. So make sure you're consulting with, if you are a lab, make sure you're consulting with the doctors that you're working with to make sure that they're getting, because they're the doctor. They should be prescribing all of these things for you. So then now here we're actually going to be designing our shell. So this is the same process here. It's asking for the insertion direction. And I'm going to use a similar insertion direction that I had before. And it doesn't need to be exactly the same. It would just be beneficial because we did all those blockouts based on that insertion direction before.
It's interesting that it doesn't carry over.
Yeah, I've always wondered that. There's Appliance Designer is a special program in 3Shape's family. It is. Every time I train somebody on this program, I always tell them that if you've used any other 3Shape program, be ready, because Appliance Designer, I guarantee you are going to run into more bugs and errors than you've ever run into in any other 3Shape program, and it's going to take probably 2 to 3 times longer to design things than it did in any other program. And has nothing to do with your computer or anything like that. It's just that the Appliance Designer doesn't receive a lot of love and attention from 3Shape. It can do some really great things, but you kind of have to know what you're doing and get very comfortable with redoing your designs multiple times to get it to work properly sometimes. So you learn, it's a very school of hard knocks kind of workflow sometimes with Appliance Designer.
Gotcha.
So this is where you were talking about we can set our thicknesses. So if we were to design with Whip Mix's very splint material, we would set that thickness here. And then the offset, what was the offset you said it needed to be?
0.1.
0.1. And you can see it's actually giving me a yellow number now and a warning. That's because the manufacturing settings that I had previously at the very beginning of the process
is
are different than what we are going to be setting here. But as you can see, I can still proceed forward with this. It's just giving me a warning and saying, hey, based on what you set in the beginning, these parameters may not print accurately, which is totally fine because we know that we're not printing with that. And then this would also be, like you were talking about, with retention amount and blockout angles. That would all be discussions that you would need to have with your doctor and make sure that the fit is comfortable for the patient. So I'm just gonna leave those alone for now because this is not actually going into somebody's mouth and I don't need to worry too much about that. Oh, no, there you go. I have to actually draw the spline for it to create the shell. Go figure, right?
Right.
So we're gonna draw the spline. This works very similar to every other spline in 3Shape. You can physically draw it like I am drawing here, or you can do a click and or a point and click method where you will just create these points and it'll draw the spline for you. Have we received any questions so far?
Let me
While I
see.
draw this.
So far, no questions in the question section. We did have a person ask how to create a case for scan on 3Shape, and so I can import to Ortho Analyzer. So they want to know how to set up a case for scanning and then go into Ortho Analyzer. I don't think we covered that maybe in the very beginning on our first one. It's been a while since we've seen that.
I don't
Maybe
have the scan software or a scanner, so I wouldn't really be able to do a good demonstration with that.
Yeah. For the gentleman that asked that, if you want to see something live or one-on-one, you can email us at productsupport@whitmix.com and then we can schedule that. Also, I may be able to find a couple training videos from 3Shape that would highlight that process as well.
I was
Uh,
actually going to suggest if you go to YouTube and look up 3Shape training, they have a training website or a training YouTube channel. And I know for a fact that that's one of those training videos that you can find on their YouTube channel.
yeah.
Yeah.
We also had another question that asked, I'm using the key splint in key splint soft, or the I think it's called the key splint soft. Yeah, actually that's what they put, sorry. And then the Envision Tech 3D printer, do you have offset levels or retention levels? We do not have that since we don't manufacture the resin, or we also don't sell that printer. I would start with contacting Envision Tech to see what they validated. If they do not have anything validated, then I would work with Keystone directly. That material is fairly flexible, and so with that, you're probably going to have a retention value. I'd probably say maybe a 0.5 millimeter or so, and then uh, for the offset, that's really, it's going to come down to how much of a friction fit is needed for the application to stay in place. So you would have to ask them, and it may be a little bit of trial and error. Our 0.1 millimeter offset is a starting point because each doctor you have and each customer you have is going to be slightly different, and so the request is going to be slightly different, and so it's just a starting point, and then you can fine tune from there. And then the gentleman that asked about the scanning aspect want to know, I know how to scan, just want to know what I select to create a case from for ortho models. And so how would you set up your order form when scanning and then design? You would go ahead and
Using
you would
Ortho
use,
Analyzer,
I believe you do scan at ortho, and then after you scanned it, once you just
you
prepare a
just
model set.
prepare a model set. Yeah, you just
Yeah.
go. As long as your databases are shared, then yeah, it would save the scan and the patient information when you scan it, and then you'll pull up Ortho Analyzer. Could be mistaken, but I think scan it if you have the model builder scan it might even be able to do some preparations in the scanning process, or you can trim and add a base if you need to as well on during that at the end of that scanning process. But then yeah, you could go into Ortho Analyzer, pull up that patient, and start preparing a model set just like normal.
Cool. That's all we have for questions at
Okay,
this point in time.
perfect. So once we created our shell, we hit next and it loads for a little while because it's Appliance Designer and it loads pretty, the load times take a little while usually. This is what you're going to see. A common misconception is, well, that's not misconception. A common thing that people want to try to do is modify the model here. You can do that. I always recommend waiting until we are done designing our bar, which is the next step, and we've combined the two and we have a final splint, because any modifications I make to this model now, if we add a bar on top of it, it might change our modifications even more in a different direction that we maybe didn't want to do yet. So I always recommend waiting until you have the full complete splint before making any modifications if necessary. But it is an option here. So we're going to just hit next though. And here's the bar design. So this is where things probably get a little, I guess, confusing. It's a little different of a workflow, but don't worry, it looks more confusing than it is. It gets very second nature as you design and as you use the program more and more. So don't worry if you look at this and feel a little overwhelmed. There's a lot of options, a lot of movements and things like that. But I promise the more you use the program and the more you design splints, the easier this all becomes. So this is the bar, just the basic bar that I designed. There are a couple of things that we want to go over here. We want to first, I guess I'll demonstrate a couple of, I guess, tricks that you can use when designing the splint. If you hold, you can see as I mouse over one of these orbs, they turn yellow and are interactable. If I hold shift though, it highlights all orbs of that same type and makes them modifiable. So if I like this design shape, but I want it to be higher or further away from the teeth, I can hold shift and click and drag, and it's going to move the entire bar while still keeping its general shape. The same thing applies with control. So maybe I just want to move these three. If I hold control, I can click those three, and then I can move just those three orbs individually, and they will keep their position together in uniformity. Same goes for all these out here as well. Same exact functionality. So that's a pretty cool feature. Most of the time I end up just using either the all or one at a time feature, but everybody's got their workflows that works best for them. So what we're going to do here is I'm going to turn off the model, because the most important feature of designing this splint and this bar and getting them to merge together correctly is right here. You want to make sure that the edge, you have a consistent edge of the splint that is not interrupted by the bar. And I'm going to leave this deliberately to show you what happens if you don't, so that if you run into this problem later when you're designing your own splints for the first time, and you run into this almost inevitably, because every single person I've ever trained on this ends up doing this. I did it. I learned from, the hard way to how to fix this, but it's a thing that I'm almost betting that every single person that makes a splint will run into at one point or another. They're going to have something similar happen to them. So I will make the error here on purpose so you can see what that looks like, but also more importantly, see how to correct it. But as you can see, there's a lot of customizability here. You do have the option to modify these later on with your regular sculpting tools, so you don't need to worry about getting them too perfect here. What you're looking for is a good general shape that covers what you're looking to cover here.
This part right here in this little section of the workflow is why I find Splint Studio so far superior.
Yes.
It's just, especially for that little gap right there, which we'll see here in a minute. It took me, so when I first started playing with the software, I didn't have any training, so I was like, oh, it can't be hard. It's 3Shape. Yeah.
That's what I said.
And then I got through it, and it was like, an hour of messing with it, 2 hours of messing with it. And I was like, this is awful.
Yeah. Yeah. It's like I said, there's a lot of customizability. So in 3Shape, and I've always said this, 3Shape is super great. It is a fantastic piece of software. The company does really great, and their goal is always to simplify their workflows so that everybody, regardless as to your technological knowledge, can use this software to be able to do digital dentistry. That's been their goal from the beginning, is to bring digital dentistry to everybody. It comes with some caveats though, because the more simplified the workflow becomes, the more restricted you are in what you can do. Whereas Appliance Designer is the only program, I think, from 3Shape that actually has the freedoms to do a lot of different things, and because of that, it has a lot more pitfalls that you can fall into that if you don't know really what you're doing, they're very easy to fall into and they're very hard to get out of. So, which is why it's great you have people like me and Corey here who can tell you what the pitfall was and how to not go into it anymore.
Right.
So I'm going to go with this bar here. I am not a splint doctor. So please don't email me personally about how awful my splint design is.
Yeah. Please email them and let them know.
Yeah.
No, and the other thing, it's not that the software isn't bad. It's just that it's so open
yeah.
due to the customization being limitless in the software that it takes. There's a lot steeper of a learning curve, and so once you know how to use the software, then it's not bad. But when you don't know how to use the software, like when I was saying, that's when it was really awful. Just not to scare anybody away. There's a steeper learning curve with this software than it is for other softwares in 3Shape, and that's the most frustrating part. Once you get past that, it's pretty streamlined.
It is. It is. So this next step is if you have the shape that you want, but you need to move the bar, the entire bar, but retain its shape perfectly, you can do that here. I have maybe used this once out of like probably the 100 splints that I've designed. It's one of those weird niche workflow portions that I don't think most people use, but it is there if you ever decide to use it. And then the modify model here, this is my same spiel from the bar portion when we had the same thing on the shell, is that you can make modifications, but you're only modifying the bar here. It's not modifying the shell and the bar together. So again, my recommendation is to wait until you have them combined. And we're going to turn those off. So here, this is where you'll see the error. So what should happen is we should have the bar up here on the top surface of the shell be combining with the shell, and the intaglio surface here should be removed. So we should have a perfect impression here. But because I already know that this is not going to work, but I want to show you what it looks like if you're designing this. And at this step of the process, I always say you need to form a habit of checking your intaglio surface to make sure that everything is correct. And you can see here, it did not remove that surface. So we have to go back. And this is where I was saying, you kind of just be ready for the idea that you're going to have to make modifications to your splint designs as you go. So we're going to pull that in just a little bit there. Pretty confident that that will work now. Then we'll add extra, combine them again. And at this time, we should see it removing all of that inner surface there. So we should have a good, clean impression where the teeth should fit. Yeah, much better.
That looks way better.
Yeah. Yes. And so then from here, this is to design or adapt the occlusal surface here. So what we're going to do, if you were to design something, if you wanted to design an upper splint, but you wanted kind of a resting point for the lower, or some natural grinding processes or articulated grinding, you can do that here. Using these virtual articulation. Let's see here. We can open up this manually to a point where however open you want it to be. The nice thing about this is you can actually turn this on, and this model set that I'm using is really not great for this, because ideally you would want all contact surface to be touching on a splint. And in that case, or in this case specifically, if this were a real case that I was designing a splint for, I would actually be going back to my bar design, and I'd be extending that bar all the way lingually so that it would actually be nesting on top of these lowers, because the lowers got such a large gap between the anteriors of the upper.
Mm-hmm.
But in this case, since we're just doing a demonstration, I'm going to leave it as is. We're going to come over here. Uh-oh, there it goes. My battery might be dying on my mouse. We're going to lock this. And so now if we come over here and we hit the play button, you can see.
With it on, it actually records the contacts.
Yeah, and so then if I turn the lower off, you can see these red portions are all portions where it's made contact with the lower. And we can hit this button, Adapt Designs. And it's just saying, hey, if you do this, it's going to be removing this contact areas would proceed. So we're going to hit yes, and you can see here it actually smooths out those areas. And then if we wanted to do some more, we can run that same exact simulation and look to see if we have any more contact with, which we don't. So that it is a really neat feature. You can mess around with that feature to get several different results as needed. So that is one of the cooler features of this is that virtual articulation process. So, but with this case, we're going to say that that's what the prescription required, and we're going to go to next. The ID tag, if you need to add an ID tag, you can do that with this feature. Most people who are using these programs, though, already have a labeling process that they use. But for this instance, we're just going to add one.
Now, do you think that would be successful in printing something like that? I mean, it
Be
will,
annoying.
but it's
You'd have to put supports on it. It would be definitely very annoying.
Can you put an ID so it's directly in the surface of it?
I don't think it will let you. Aha, you can. I
No,
know
no.
the intaglio surface is actually protected when you use the modify model step, but
What about the tag type down on the bottom left of the screen? Detachable, integrated. You may have to. Oh snap! So it looks like you can put a positive.
Perfect.
Nothing more annoying than having your name being pressed into your cheek.
Perfect. Yes, because every single person who I've ever designed splints for wants a very large protruding label, obviously. But yeah, you can do that if you want to. Again, most people I know who design these have an external labeling process, and most of them are going to be in a much less noticeable position or no label like this at all even. So we're going to just leave that there though and go to next. This is where, Corey, you would probably have more knowledge about this portion than I would ever have, but this is for drill compensation if you were going to mill your splint rather than print your splint.
Absolutely. So what this is going to do, go over and flip over the other side and let's see if it, so turn off the skip this feature. And then let's go ahead and hit preview. And let's see if it changes that intaglio surface in any way. So anything that has a radius less than a 0.5 millimeter, it's going to compensate for it. And really what we're compensating for is the smallest radius burr that we're going to have milling the internal surface. Let's see if it actually makes a difference. It may not for this, but if the burr can only get so small, and so if there's a really sharp angle on the intaglio surface, the mill can't achieve that detail. And so if it can't achieve that detail, your actual splint will not fit for the patient at all. It'll be high or too tall. And so you always want to have drill compensation turned on with the drill radius fixed to the smallest burr that will be actually utilized for milling the internal surface. Did it do a thing?
It's still applying. It got to like 98% and now it's doing it again.
So we may have broke Matt's computer.
No. We might have. It's still going. As long as that number's still moving, I'm inclined to let it run its course. But yes, this is a feature I have literally never used or played around with. So I'm glad you're here.
Thank you. I'm glad I'm here too. So while looks like we have a question that came through, so let's see what this actually says. Question maybe premature, but how or when are anterior ramps developed?
Oh yeah, that would be back in the bar process. So if you needed an anterior ramp, you would, instead of having a flat occlusal surface like I designed with my bar, you would take some of those orbs and you could just raise them up however high you'd like. But that would be that step there.
Very good.
It's a good question, actually. I had more and more demand for anterior ramps the more I started designing splints. So
In the Splint Studio software, which we do have quite a few webinars on that already fabricated, and
mhm.
so if you want to see the Splint Studio software in greater detail, or just to compare it to the software, you can actually create the anterior ramp for a disclusion in like 2 seconds. It's
Yeah.
extremely easy to fabricate versus this, you'd have to manually sculpt or change the angulation of that bar when fabricating it. And so it's a little bit further, I guess. Um, I don't want to say
It's
automated, but it is automated.
it is. It has more engineering
Yeah.
behind it than Appliance Designer does. So this would be where if you wanted to smooth out some of these edges between the bar and the shell. Also, if you wanted to get rid of these parts, especially on the the lingual surface, to prevent any tongue habit forming, or if you have any grooves that are deeper. And this uses all the exact same key shortcuts that Ortho Analyzer does for their wax model. The wax knife settings. It's the exact same tools that you use in that process. And you can see as I come in here into the intaglio surface, it will not let me sculpt. So
Nice and protected.
nice and protected. Probably the best feature, honestly, when you're designing this as a technician, because you can get in that autopilot state. And the worst thing is if you have, like I'm doing here, a long motion and you accidentally are smoothing something for a few minutes and then come over here and mess everything up and you lose that entire movement because you were on autopilot mode. But anyways, none of us are on autopilot mode ever because we're all really good employees, right?
Right.
But yeah, so that would be if you needed to smooth out any of these designs, you could do that with this. You could reduce the thickness overall of your entire splint, but because we did the splint thickness exactly at a minimum thickness, we don't really want to be messing around with that. One thing I do want to point out that actually is a very good tool to use here is the cross-section tool. I'm going to draw a cross-section here. The best thing to use the cross-section tool for, in my opinion, is to measure. And so we can measure the thickness of the splint here and see that it's 2.34 millimeters thick at that point. Or we could measure, see where if we could find the thinnest point of the model. Or if I were to, for instance, turn on the upper and lower, this is actually what I used this for most of the time, was when I was designing these to get a good reading on how much space was existing between my molars. And so we can click this point here and that point there. And then the best part is that it actually draws a right angle and then tells you the height between those 2 points, which is This number right here is very important for designing splints, especially if you're designing night guards or anything like that. You need specific measurements in that regard. So this tool actually becomes very, very handy for people in that design step. So very handy. The Splint Studio I discovered. Unfortunately, and don't ask me why, because this is the same question that we have for all of 3Shape's programs, why they don't use the same functions in every single program that they have. They have a cross-plane or a cross-section tool in Splint Studio, and they have a measurement like this, but it does not draw the right angle and show you those measurements. It only shows you this distance. So just a heads up, if you ever are trying to do this in Splint Studio and you're wondering why it's not working the same, that would be something that we could maybe form a petition and all of us sign it and get 3Shape to have all of their programs be on the same page. That might be the best route of action there. So, but that's pretty much it. As far as splint design goes, the next two steps are just validation and the finalization, which ultimately is just the program getting the splint ready for printing and being done so that it's all set and prepared to go. Any questions or things that you would like to point out, Corey?
No, not this, not from me personally. However, I don't see any questions here coming through. Let me check the Facebook page. I know we are streaming live.
Sure.
If anybody has any questions about what Matt is showing at this point in time, please feel free to ask. If not, we'll assume that you're doing another excellent job.
Yeah.
In this process.
And this is supposed to be for basic splint design. So there are some doctors who are using this program to design more complex splints and sleep apnea devices. If you are looking for that type of information, I don't have a whole lot of information to be able to give out, simply because this program is just not designed to do that. But there are some workarounds. So if you are looking for more information for that, you can feel free to send us an email. It's productsupport@whipmix.com. And we'd be happy to give you any tips and tricks that we have to be able to get through that. But again, that's much more advanced designing processes. So I wouldn't recommend jumping straight into designing those things with this program. I'd start with designing simple things like this for a while until you get more comfortable with the interface and how the program works before you start jumping into something like that.
So we had a couple of people thank us for our time at this so far, but no questions yet.
Okay. Oh, there's a very important, super duper, like supremely utmost importance point to make as soon as I get to this maxillary finalization.
While that's loading, we had a question that came through that wanted to know what articulators do you use. Do you know what all articulators are validated for Ortho system?
I don't. I know there's quite a few.
Okay.
But I don't know any of the brands.
I know you can.
Off the top of my head.
I know you can change the articulator.
Yeah.
But it's only what is validated for the system. Go ahead for the person, Sam, who asked that question, email us at productsupport@whipmix.com, and then afterwards we'll go ahead and provide that over.
Yeah.
And then we had another question. Are you planning a webinar more detailed on adjusting the function of the splint using virtual articulation? Not this time, no. And so we don't have any plans for that. However, if you want to see a one-on-one session with that, please email us again at productsupport@whipmix.com.
Absolutely.
I think we had another question pop through. What design program would you use for anterior guidance? I would recommend Splint Studio, personally. And that's through 3Shape. So it's 3Shape Splint Studio, depending on what software packages you have. If you buy Dental System Premium, it comes with it. If you buy Dental System Complete Restorative, it comes with it. And if you buy one of the more basic packages like Crown and Bridge, it can be added on as an extra module itself. But we
Unless
do
you have
video.
an occlusion like this one, where you have a very wide gap, then you might want to use something like Appliance Designer. But
Right.
it can be done in Splint Design as well. I have done it. So I almost forgot to show you and make a very, very distinct point about this, because this is the most frustrating point of Appliance Designer. If we come over here to the finalization process, the save process, so everything's saved now. Most people, because everything else, literally every other aspect of 3Shape does this, most people would hit done, and then they could export the design from the patient browser. Not an Appliance Designer. If you do not export using this button over here, you will not be able to export your design. You will have to go through the entire process again. It will save all of your steps and automatically perform them for you, but you will have to sit there through all of those loading times again. It is the most frustrating thing to do. Take it from me. I've done it dozens of times and I somehow still did not learn. This is the most crucial aspect. If you learn nothing else from this webinar, please learn this one step. It will save you, I'm not even kidding, it'll save you hours of time. To make sure to come in here once you're done with your design before leaving to export here. And you can export the models if you want to print the models as well as your splint. So make sure to always export your models before hitting the done button.
we
Thank you for coming to my TED Talk.
Yeah. I wish we should do TED Talks, just do like dental TED Talks. I really enjoy.
Yes.
I don't know if anybody here watches the TED Talks, but they some of them are really good.
They are.
So we do have a couple more questions that came through. One was from a current customer of ours and wanted to know why the Splint Designer that they have does not look like ours. It could be updated, but also it could be that I believe that question or this user only has the Splint Designer that's integrated with Dental System. We are going through Ortho System, so it may be structured a little bit different there. We'll have to confirm that. But if there's an update, we can go ahead and update it. Then we had another question related to the actual webinar. It says, I'm a novice in this area, an ortho technician trying to break into digital world. The lab I work at does not allow time to work on software. How can I work on software as a practice to gain the skills for design? After hours, buddy. So we, really the best way, if you're at a laboratory and if you want to learn further, I would talk to the owner of the laboratory and just let them know that it feels like your growth is being stunted and you want to be able to expand the knowledge base of your team further. If they're not willing to, I guess, allow that, then you may be able to do something after hours at the laboratory, or if they're not allowing growth, I mean, no offense to the owner, but that may be a sign.
I'm glad you said that, because I was going to say, if I was in that position and you have some experience that you're looking to expand into digital, which is the future of dentistry, that's where the market is going, you might start looking into other labs that are offering that kind of thing, and say that you're interested in doing that, because I know a lot of labs are looking for technicians who want to take their skill set and their knowledge and apply it in a digital format, because a lot of, actually, from firsthand experience in an ortho lab, what our number one question for hiring a new digital tech was, do you play video games? Not, do you have dental experience? Because so much more skill set from playing video games and tinkering with technology is applicable than the knowledge. You can gain the knowledge for dentistry later, or through experience, but you can't force somebody to want to be a digital technician. And so that's
and it's funny that you say that, Matt, because if you're to look at our team that we have Matt Davis, he's a gamer. Evan
Yeah.
Kemper, he's a gamer. Bryce Hiller, he's a gamer. We have me, I'm not a gamer.
Yeah, but you're a
But
tinkerer.
I'm a
You build like
tinker.
dirt bikes and
Yeah.
four-wheelers and stuff like that. So you're mechanically minded.
We did have actually one more question, then actually a comment. So um, our good friend from Colorado actually said, if you want to learn more, YouTube, and there are
Yeah.
tons of videos on YouTube, but you will. There's a little bit of the hands-on element that does go further, and so start off with watching all the YouTube videos that you can, and then when you go to I guess proposition the lab owner about spending more time at the lab and just I mean if you really want to learn more, maybe it's of value to not even get paid for it to you. I mean
Mhm.
just do it on your own time and out of your own um sacrifice. But there's tons of YouTube videos that are available
Yeah.
um for that. um do we see any fit problems? So fit problems, it's I mean, you can always see a fit problem in your design process. Let's say if you didn't design it right with the proper settings or offsets for the material and printer combination that you're using. Absolutely. You can always see a fit problem. However, if you follow the IFU for the material and the resin and the printer you're using or the mill and the PMA you're using, then your fit problems go away drastically. And there is a little bit of like a flirtation with the software when you're applying undercuts and um, in the insertion angles. And so there is a little bit of a learning curve there as well. But once you get it dialed in, your fit problems are essentially eliminated.
Yeah. And working specifically, if you have one doctor that you're working with or a couple,
Yeah.
I would work intimately with one or two until you get a good fit and a good system, and then open it up to more. Because if you have 17 doctors that are all saying this doesn't fit, this one's too loose, this one's too tight, it's going to be a lot harder to narrow down your design process to something that's consistent. And in splint design, consistency is
Yeah.
paramount.
Um, and then we had another question that they wanted to know. Uh, excuse me, what is the cost to get into digital for ortho? And so if you're looking just for the scanner and design, you can get in maybe for maybe 12, $13,000, and then you'll need an output of some sort. And so that'd be a 3D printer or a mill. Um, I mean, you'd be looking at maybe another 10 to 15 to, I mean, well, really you can spend as much money as you want.
Yeah.
But bare minimum, I would say 25 to $30,000, you may be able to get into uh, digital. What I would highly recommend for anybody that's interested in getting some proper quotes. Now, me and Matt, we are like the furthest removed from pricing, so don't take that for
No.
take that price as a grain of salt because we're strictly on the tech support side and training side. Um, I would go ahead and if you can email us at productsupport@whitmix.com and provide us the location that you're looking for, or sorry, location that you live in. So I can hand you off to the proper sales rep here in North America. So if you're located here in the U.S., I think the upper half of the country, so it's divided right straight down the middle from East Coast to West Coast. The upper half, I believe, would be Cassandra Dombrowski, and then we have Sherry Weatherby for the lower half. And
Mhm.
so email us, and I'll provide you the contact information for the proper sales rep for you. Um,
I was
just
going to say for an ortho lab just starting up, ortho labs, you have a lot lower um, requirement for print accuracy.
mhm,
You can print at 100 microns, and as such, that it kind of opens up your printer options a lot more than maybe like a Crown and Bridge lab because they need that really small micron printing accuracy. And you could drop down. I would, as if you're just getting into it and just wanting to dip your toes in, I would recommend starting with something simple like the Whitmix Varibuild, very
yeah,
small, short run printer. You can print a couple models at a time. It has a lot of, you'd be rotating prints, so you'd have somebody having to do stuff more often. But I think the biggest misconception in digital dentistry, and especially on the orthodontic side, is in order to get into that, you have to have like a carbon printer, or a carbon and a Formlabs and all these other things. You have to have 10 Formlabs printers, but you really don't. It all depends on how much input and output you'd have. And if you're just starting and you're wanting to just get your toes in, a small short run printer like a Veribuild is a
Yeah.
really great way to start.
Yeah. And if you, I mean, and to expand upon that, Variabuild is a great way to get started. And then as you start to increase your growth, I mean, I'm I am 100% biased. Don't get me wrong. I think Asiga makes the best printer in the world. But I've also played with a lot of other printers, and there's the overall quality of the Asiga, the speed of the Asiga, uh, just the performance of everything, and the openness. There's over
Mm,
350 validated resins for
yeah.
the Asiga printer, and I think actually that number is wrong. I think I'm actually short now on that. I think it's probably closer to 400 or 500 at this point in time. Um, and so there's a wide range of resins that you can use for your printer, and whether it's in ortho or it's in crown and bridge, or uh, you know even on an industrial side. So I mean, it's depending on where you want to go. There are multiple options, and just make sure you do your research thoroughly. Um, let's see here. We did have um, I think this was a response to the gentleman that wanted to know about getting into more digital. Um, and how do I learn more? And from a technician to technician, this is coming from the chat. They said quit and open your own lab. Um, and they said I did, and I don't think that that person is regretting it in any way. We had a couple of questions about, are these CE credit course? Absolutely. However, there is a test that you'll have to take. So at the end of this session, in the next 2 days, you will receive a list of it's 10 questions from Matthew Davis, and you'll have to answer those questions, and then you'll be able to get your CE credits for it. And then also we had one last question, not related. Who's going to win the Super Bowl on Sunday? So it's between the Kansas City Chiefs or the Tampa Bay Buccaneers. I'm gonna say probably the Chiefs, but I'm rooting for the Buccaneers just for Tom Brady, um, and hopefully he'll retire. We had one more question. Where can we get a copy to watch this again? We actually have a knowledge base on our website. So if you go to whitmix.com, and actually I need to navigate to it. So if you go to whitmix.com, and I believe it's under resource library. From there, we will find a full list of webinars and our digital dentistry series. And so there's a full list of videos and resources there. And it's at whitmix.com and then technical resources. All right, let's see here. We had one more question. So we're going to have one more question and then that's it. What is your opinion about the Envision 3D, the new 4K one? I haven't seen it yet. I haven't been able to compare any prints to it. Nothing. I can't knock the printer itself. I'm not a big fan of Envision Tech in general. I'm sure it's probably a good printer. I'm just trying to be as unbiased as possible. I've heard a lot of horror stories from users that had Envision Tech in the past for support and performance. Maybe if they've turned that around on that end, it may be a solid printer. But it's kind of hard to something that maybe had issues in the past. But it may be a good printer. I don't know. We haven't had a chance to compare that one yet because it is so new. Hopefully we'll be able to see that at shows someday whenever that gets back up and running. Oh, I just got a notification. There are some questions on the Facebook page as well. Hang on. What program do you recommend to make night guards?
Probably Splint Design, Splint Studio.
Yeah, I would say Splint Studio as well.
It's their newer one. It's going to get a lot more love and attention moving forward, almost guaranteed. So if you're wanting something that you're pretty guaranteed to have updates and support on moving forward, that's where I would go. It's simpler design too. If you're just doing night guards, that's pretty easy.
Yep. Awesome. Well, that's all I have. Everybody, thank you so much for attending. A lot of really good questions that came through. Matt Davis, thank you for your time and your knowledge and your expertise as always. And once again, if you guys have any questions, email us at productsupport@whitmix.com. We're here to answer you and support any digital questions that you have. And we'll see you later.
Yeah. Thanks, guys.